Hi everyone. So today we're going to go through the concept on inverse function, all right? And we're going to understand what really is an inverse function and how do we find it, both for a linear form as well as a quadratic form. All right, so let's start by definition. So what is a linear function? So we can define it as a function that undoes what the original function actually has done. So, for example, if I would input, for example, fx equals to 2x plus 1. If I'm going to input 1, then my outcome will be basically 2 plus 1, which is 3. All right? So what an inverse function will do is that it will reverse kind of the process. So if I have the inverse function itself and I would input 3, which is kind of like the output for the original function when I input 1, then the outcome will be 1. So think about it as like a in and out situation. You put in x, you come out y if it's a function. If it's inverse, you input y, you come out x. All right? So as such definition, so we need to then find out how is the relationship between fx and the original function and with the inverse function. Now, there's some sort of relationship here. So first, we can write the inverse function as f inverse x. That's how we write it. And we say that the domain of the inverse function will actually be equal in a sense to the range of the original function. Now, similarly, the range of the inverse function will therefore be the domain of the original function. Now, you may be thinking like, okay, every function can be an inverse function, and that is actually not true. There is a rule, and the rule is very clear, is that only one-to-one function has an inverse. Only one-to-one. If it's not one-to-one function, and you won't find an inverse. Now, let me give you an example very quickly why that is true. Okay, let's say I have the function y equals to x squared. All right. Now, what happens is that an inverse basically reflects whatever function you have along the y equals to x line, right? Let's call this y equals to x line. And if I would inverse it, you will notice that it will look something like that. The rate graph. Now, you may think, what's wrong with it? Looks okay. Now, the problem is that the rate graph is actually no longer a function. All right? It has one input but two outputs. All right? So, therefore, you cannot inverse a many-to-one function because you will end up having a one-to-many situation, which is basically not a function. Okay? So, have to remember only one-to-one function has an inverse, and that is going to be always true. All right, so let's go through the process of how to inverse a function. All right, so let's look at example. If fx equals to 5x minus 2, so the first step is you want to let y be fx minus 2. All right, next, you want to then try to isolate x as a subject. So I'll move 2 over, and x will be isolated as equals to y plus 2 over 5. When that happens, you can therefore state that your inverse function will be x plus 2 over 5. You kind of want to replace the y here with your x. All right? So that is really the process of how you inverse a function. Now, there are other situations as well. Let's look at another example, especially in a quadratic graph. How do you inverse a quadratic function? All right, let's look at this example. Now, let's say fx we will have x squared plus 10x. We have minus or plus 24. Okay. So if I want to inverse this function, and this is a quadratic function, we need to understand first, a quadratic function is not a one-to-one function. So there must be some caveat or some rules that restrict its domain. And usually it will say that x must be, let's say, more than minus 5, for example. Okay? Now, essentially this domain restriction makes the quadratic function a one-to-one function. So instead of you drawing a whole entire graph like that, you may end up only drawing halfway. All right? So what is the process like to find the inverse of a quadratic function? We have to actually use completing of square, all right, to make the quadratic expression into the vertex form before we can find the inverse. Okay, so let's proceed on and let's see. So we're going to let y be equals to x squared plus 10x plus 24. Next, we are going to complete the square. So we have that square minus 25 plus 24, which leads us to this situation, which is minus 1. Okay, so now I know my vertex. My vertex in this case will be negative 5 comma negative 1. And since I only want this part of the graph, because x will be more than minus 5, I'll be looking at the positive version of the function, the inverse function. Now you say, what do you mean by positive version? Later I'm going to show you why is there a positive and a negative version. Alright, let's have a look. So we're going to proceed on to inverse a function by isolating x. So y plus 1 equals to x plus 5 square. Now I'm going to bring the square and square root y plus 1. And notice that when I square root y plus 1, I have to have plus and minus. Alright, one more step. So x will be equal to negative 5 plus minus the square root of y plus 1. Okay, so that's the dilemma here. Which one do I choose? Do I choose a positive or the negative version for my inverse? So it really depends on what you want. If your domain restriction is to the right, more than minus 5, then we choose a positive one. If your domain restriction is to the left, like say less than something, then we will want the part to the left, to the negative version. All right? So therefore, in this case, our inverse function would be equals to minus 5 because we want the part to the right, so plus square root of x plus 1. Okay? All right. So that's how you find your inverse function itself. Okay, now let's do a quick conceptual understanding question, whether you understand inverse function or not. Okay, let's say I have f1 equals to 2. All right, you don't really know the function. So what happens if I have f inverse of 2? What do you think the outcome is going to be? Yeah, it's going to be 1, right? So the input now becomes the output, and the output becomes the input. Yeah? So the output for fx, which is 2, now becomes the input for the inverse function. And your outcome, or your output in this case, is going to be the input of the original function, which is 1. And yeah, that's how you get it. Okay. All right, so mainly this is the process of how you find the inverse function. And some things to take note of, especially when it comes to inverse function. There's some rules with regards to it. Number 1, of course, we talk about one-to-one function only can be inverse. And also that if you were to do a composite function of the inverse itself, or vice versa, your outcome will always be x. All right, it's always going to be x. All right. The next part is how do we sketch an inverse function? Now, I briefly mentioned it earlier on, all right? So, for the original function and the inverse, now I'm not going to sketch a full graph, but I just want to share with you the concept. Let's say my original graph is this, and cuts at A here. Now, the inverse function itself will be the reflection of the original graph along this y equals to x line. All right, along the y equals x line. So when it cuts the y-axis at A, now it will cut the x-axis at A. All right, and it will be a mirror image of the graph along the y equals x, right? So almost like a reflection. So it's kind of like, sometimes you look at butterfly, wings, it's symmetrical. Yeah, it is symmetrical. And it always be symmetrical along the y equals to x line. Okay, so mainly that's how you graph it. If you have any questions on how to solve inverse function, you will definitely sometimes have to graph it. Sometimes you have to also understand the concept behind it. And sometimes people ask, okay, so what happens when you equate fx equals to f inverse x? What's going to happen? Now, two things can happen. If they were to intersect each other, okay, let's just say, for example, I draw an inverse function like that, and the original function as that, and the intersection is here. Now, one thing will always happen is that the original function and the inverse will always intersect when y equals to x, which therefore means that you don't really have to solve fx equals to f inverse x if you're asked to solve. You can solve a simpler version by saying that it's the same answer if you equate fx to x, or you equate f inverse x equals x. Now why? Because both the function intersect at this point here, and this point here is exactly where we will find y equals to x. Alright, so they both intersect the same position at y equals to x. Yeah? Alright. Okay, so that's all for inverse function. You will have a lot of practice, and I'm sure you will find some question that will confuse you. But don't worry, try this and understand the concept. If you're not clear, watch the video again. I hope it will help you to master this topic on inverse function. Alright, I'll see you in the next one. Cheers.